All right, so now let's start going over this iterative process, um, and this is really cool, and it's going to be a really cool way of using your calculator too. So let's let's get some stuff down. We know that our local linearization L of x is the derivative, which is our slope at our first x value, what we think is the 0, times x minus that x value plus the y value there. So f of x sub n. So just to be very clear, here you got your function. If we're predicting the 0 is there, that's x sub n. Here's f of x sub n, and this has a slope that equals f prime of x sub n. So we get the line, slope, and then our point. So the zeros, when we approximate the 0 with this line, that 0 is there's always going to be a 0 there. And when we solve this, I was hoping that in the last videos it maybe was getting clear. When we solve this, we're going to move this term over, so we get minus f x sub n, and then we're going to divide by this, so over f prime of x sub n equals x minus x sub n. And what we're looking for is this. So that x value equals, moving this over, x sub n minus f of x sub n over f prime of x sub n. And this gives me, I'm going to say n plus 1, where x of n plus 1 is my new 0, and where it's the center for my new line, for my new L of x. And the idea is this. Here's how we can use our calculator in a very nifty, cool way. So here's how we go. If we say that each subsequent 0, x sub n plus 1, equals, well, equals x sub n minus f of x sub n over f prime of x sub n. What we can do is we can say, all right, let's take this function and let's put it in our calculator. So let's put that function in our calculator. Here's our calculator. And so x cubed plus x minus 1. And in y2, we're going to put the derivative. So for those of you without an 84 right now, I apologize. I'm sure there's a clever way to do it on your calculator, and hopefully we can figure that out. But for now, this is for 83s and 84s. So then what we're going to do is we're going to say, okay, I've got my function here, and I'm going to go to my home page, and I'm going to say, I think my 0, well, we're saying my 0 is 0. X sub 0 is 0. So we're going to take 0, and we're going to store that in as x. And then what we're going to do is we're going to start this iterative process. So we're going to do this right here. We're going to say my next x value, my next 0 approximation will be x. And I've stored x right now is stored as 0. So minus f of x. So I'm going to do that as y of y1 of x divided by my derivative. But here this is y2. So vars y2 of x. So what this is going to do is it's going to calculate my next 0 using this equation here. And this equation is that equation that finds the zeros of my linear approximation. So if I press enter, That approximates my 0 at 0.99999. Well, that's good. So that's going to bring me over here to a line that's like right there. And if I press enter again, now this is x. Now x is stored as 0.999. I've made x that. Oh wait, no, I haven't yet. Sorry. Whoops. Then what you need to do is, whoops, second enter. You need to store all of this. Yeah, here we go. Store all of this as x. So whatever value we get, it's going to be now stored as x. So 0.999, now that is stored as x. So when I press enter again, it's going to put this 0.999 value in for x. And now it's approximating my 0 is 0.7499. And if I press enter again, it's going to press this approximation of my 0 in for x, x, x. And now I got 0.68. And now this is my third iteration, my third approximation for the 0. And now I'm going to plug this x value in for x and x and x. And as I keep going, I'm getting towards pretty much an exact answer. So I've now done 2, 3, 4, 5, 6, 8 iterations, and I'm getting down to a pretty exact number. And I'm pretty confident that this is my 0. And let's just see. This is now stored as x. So x cubed plus x minus 1. So this value of x is 0.68, and that's the value that I'm saying is my 0. So if I put this x into my function here, it should equal 0, and it in fact does. So that's a cool method of using the calculator to generate those iterations more quickly, so we don't have to do so much plugging and chugging. That's it. That's all.